everyone. Happy Monday. I'm sorry I can't be there today, but I hope that you are nice and respectful for the sub. Mr. Jason should be there if you have any questions as well. But I've made a video lesson for you today to follow along with, and we can just pretend like I'm actually there and we would just be doing a normal lesson. So go ahead and make sure that your phones are in the phone slots. Make sure that you have grabbed a calculator and a pencil, and then after the sub passes out the notes pages, then you can go ahead and get started. So today we're going to be talking about outliers, and we're going to look, and we kind of looked at this a little bit on Friday about how changing the data or adding or removing points could change the mean, median, IQR, standard deviation. But today we're going to specifically look at outliers and how those affect the mean, median, IQR, or standard deviation. So go ahead and take a few moments to pause this video, read the warm-up, and then we'll go over the warm-up and everything together. So if you haven't done the warm-up yet, I'm going to give you one more chance to pause and to do this on your own. Take a good 5 minutes, and then I'll go over it. Alrighty. Okay, so the histogram and box plot show the average amount of money in thousands of dollars. So we want to make sure we know that these numbers down here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, those are technically in thousands of dollars. And so I wouldn't read them as 1, 2, 3, 4, 5. I would read them as 1,000, 2,000, 3,000, and so on. So the histogram and box plot show the average amount of money in thousands of dollars spent on each person in the country per capita spending for healthcare in 34 countries. One value in the set is an outlier. What could the outlier be? When you are looking at the histogram and the box plot, it's actually hard to determine the outlier visually from the box plot. However, it's a lot easier to determine if there's an outlier from a histogram, because if I notice, I have a big gap here between 7, 8, and 9. And that really big gap there tells me that the data is really spread out. And whenever I see histograms and they have a gap there, or really a gap anywhere, then generally the value or the next value that I see, in this case there's a bar here between 8 and 9, statistically I would assume that there could be a possible outlier located there on that next bar. So one value in the set is an outlier. What could the outlier be? We would say that there could be an outlier between, and we sometimes use the word possible outlier, but between $9,000 and $10,000. All right, so that's what we would just assume as a possible outlier. Now I'll have to talk to Mr. Cordero and Mr. So to see what we are going to decide for your test on Friday, but there is a formula for finding an outlier, and I'm going to assume that you're going to need to memorize this formula, but I'll let you know after I talk to them whether or not we'll give you this formula or not on the test. But this formula here, quartile 3 plus 1.5 times the IQR, that formula there helps us determine if we have an actual outlier or not. So I'm going to use the box plot to get my quartiles, and then I'm going to use that formula to determine if there is an outlier or not. So I'm going to kind of estimate. I know these aren't exactly the numbers because they're decimals, but I'm just going to estimate. I'm going to say quartile 1's about 2 because it'll make my life easier. And I'm going to say quartile 3 is about 5. So if I am trying to do use the formula to figure out if there is a possible outlier or not, I'm going to use that formula there. So quartile 3 is 5 plus 1.5 times the IQR. The IQR is always quartile 3 minus quartile 1. Now, if you want to pause this video and look up why it's 1.5 times the IQR, you're more than welcome to. We don't really dive too deep into it, even in my AP Stats class. We just don't really have the time. But if you're interested to know why or where that formula comes from, you're more than welcome to Google it, and I'm sure Google Gemini or something will help explain or show it to you if you are interested. All right, I'm going to use my PEMDAS or my order of operations to go ahead and simplify this. So I have 5 plus 1.5. I always start with what's inside the parentheses. And then I'm going to do 1.5 times 3, which is 4.5. And then I'm going to add 5 plus 4.5 together. And so I get 9.5. And I want to remember that this is in thousands of dollars. So really this represents $9,500. If I think about it, 9,500 is in fact in between 9 and 10,000. And so technically that formula did help confirm that there could be a possible outlier in between 9,000 and 10,000. We don't know it for sure, but based off of what we've seen so far, I would say there's definitely a plausible one there. So let's use the data that was used to create the histogram and the box plot. Let's actually look at the data from the warm-up, and let's use technology to determine if there really is an outlier and our mean and all those fun things. So I have all of the data here. Remember, this is in thousands, so 1,100, 1,100, and so on and so forth. I'd like for you to pause and go to the website from yesterday. And actually, I think the website is spelled wrong here. I think it's supposed to have 2 P's for Staplet. But I would like you to go to staplet.com, and I would like for you to type all of that data in. And then I would like for you to find the mean, the standard deviation, and the 5-number summary off of that website there. So take a moment, if you don't have your laptops already opened, or the sub where Jason can turn the computer on and you can do it all together on the big screen. I did spell it wrong. It is STAPPLET, so make sure that you type in the correct search engine there. Then you're going to pick one quantitative variable. And once you pick that, you're going to type all of the data into there. You do need to give your variable some sort of a name, so make sure that you type in to this variable name part up here that we're talking about per capita health spending by county, or by country, excuse me, by country. So go ahead and pause this video, take about a minute or two to type all of the data in. And then once you've typed all of the data in, you can go ahead and pick Begin Analysis, and it'll give you all of those values that it's asking for on your notes. All right, so if I look at this data set here, I've already typed all of my data in to the applet online. And when I did that, I got a mean of 3.694. I got a standard deviation, and I don't want to round these. I want to keep the decimals that I see to 1.842. And then for my 5-number summary, my minimum is 1.1. My first quartile is 2.1, so we were pretty close when we said 2 in the entry task. My median is 3.45. My third quartile is 4.8. And my maximum is 9.8. And remember, this is in thousands, so we're just using that there. All right, so I have my 5-number summary, and I have my mean and my standard deviation. The maximum value in the data set represents the spending for the United States. Should the per capita health spending for the United States be considered an outlier? Explain your reasoning. So whenever you're trying to determine if something is an outlier and it asks you to explain your reasoning, it's asking you to use that formula from the entry task or use algebra to show if there is or isn't. So we're going to use that formula, Q3 plus 1.5 times the IQR, to determine whether or not there is an outlier. So quartile 3 is 4.8 plus 1.5 times the IQR, which would be 4.8 minus 2.1. Now use your PEMDAS, so do 4.8 minus 2.1 first, and you should get 2.7 multiply that by 1.5, and then add it to 4.8, and you should get 8.1. Now, how can we use that 8.1 to determine if the maximum value is an outlier or not? Well, if your maximum value, if the maximum, which in this case is 9.8, if it's larger or greater than what we just found using the formula, then the answer is yes, we would consider that to be an outlier. So when you're trying to use the formula, if your maximum or any other data point is larger than that number you found using the formula, then you would say yes, there is, or yes, we would consider that to be an outlier. So yes, 9.8 is an outlier. Although outliers should not be removed without considering their cause, it is important to see how influential outliers can be for various statistics. So what I would like for us to do now, it's kind of what we did yesterday when we or on Friday, when we added and removed data. But I would like for you to remove the value that we just had for the United States from the data set. So I'd like for you to go back to the Staplet, and you can once again either do it individually with an elbow partner or up at the front. And I'd like for you to remove that 9.8 outlier, and then I would like for you to find a new mean, a new standard deviation, and a new 5-number summary. And we're going to look at how removing that outlier affected those numbers. I'm going to go ahead and I'm going to pause and let you go ahead and do that. Please do it on your own because I won't be there to hold your hand on the day of the test. Well, I'll be there, but I can't hold your hand on the day of the test. So make sure that you can do that, okay? So go ahead, pause, and take a few minutes to find your new mean, your new standard deviation, and your new 5-number summary when you remove 9.8 from the data. All right, the new mean I got was 3.509 when I removed the outlier. The standard deviation I got was 1.519. Oh, not 19, 516. 1.516. My minimum is stayed the same, so my minimum is still 1.1. My first quartile also stayed the same at 2.1. The median is almost exactly the same, but changed ever so slightly to 3.4. And the third quartile is now 4.75. And obviously, since I removed the outlier, the maximum is no longer 9.8, but it is now 6.6. So I want us to look at these numbers now, and I want us to think about what we did yesterday. And I want us to think about how the mean, the standard deviation, the median, and the interquartile range changed. So how did the mean, the standard deviation, the median, and the IQR change? So the first thing is that if we look back at what we got in the previous problem when we had the outlier, the mean originally in that problem was 3.69, and when I removed the outlier, it's now 3.509. So the mean decreased, which is what we also found out on Friday. If you were to remove a large outlier, it's going to cause the mean to decrease or get smaller. Same thing with the standard deviation. Standard deviation with the outlier was 1.842. Without the outlier, the standard deviation also decreased and is now 1.56. That should make sense because now my data values are not as spread out with that outlier. Remember, standard deviation is about, give or take how far all the points are spread out specifically from the mean or from the center. So if I remove a point that's really far away from the data, that's going to cause the standard deviation to get smaller. Now, something to look at for the mean and the median, excuse me, in the IQR is that when you look at the decimals, the median and the IQR did change, but they did not change as significantly as they did for the mean and the standard deviation. So, for example, the median for the original data was 3.45, and now the median is 3.4. So the median like barely decreased. It did get smaller because I changed the data, but it did not get as small or change as drastically as the mean and the standard deviation did. Same thing if I were to look at the IQR. The IQR for this data here would be 4.75 minus 2.1. So you always kind of have to calculate the IQR. It's a little bit harder to determine if the IQR has increased or decreased just by looking at the 5-number summary. You might be able to use some intuition to determine it, but overall, you're going to have to type things in and do some math. But you should get, 2.65. And so if I look at my previous IQR on the page before, I had an IQR of 2.7. And now I have an IQR of 2.65, which essentially is almost the exact same value. And so the same thing with the IQRs, the IQR barely decreased. Whenever you remove data, it will change the numbers. It will change the mean and standard deviation and median and IQR. But what I want you to be aware of is that this, once again, is a reason why we would use mean and standard deviation for symmetric data. And that's because the mean and the mean and standard deviation are highly affected by outliers. And that's why you would use the median and the IQR once again for skewed data. And that's because those are not affected as much by your outliers. You're definitely going to want to continue to embody that. Mean and standard deviation are used for symmetric data because they don't care about the outliers as much, whereas the median and the IQR do. So you use median and IQR for skewed data. All right, just a few more examples here that we're going to look at just to make sure we're all on the same page. So the number of passenger electric vehicles registered is collected for the 39 counties of Washington State. And here are some summary statistics. So I have the mean of about 3,500 cars, a minimum of 3 cars, quartile 1 is 170, the median is 506, quartile 3 is 1,560, and the maximum is 73,996. So we have an extremely large spread out data set here. I want you to start by looking at the mean and the median, and I want you to notice that the mean is 3,589 cars, and the median is 506 cars. So I don't have a picture of what this data looks like. However, if I go back to my notes from previously in the week or 2 weeks ago, I know that the mean is greater than the median. And we took notes on what shape distribution always has the mean greater than the median. So if the mean is greater than the median, that means this is going to be skewed data. And technically, the mean being greater than the median means that my data is skewed to the right. That's helpful because that's going to tell us that if we have any outliers, they are going to be possibly really large values, really large outliers. All right, part A, are any of the values outliers? Use algebra to show your reasoning. So anytime I see that phrase there, you're going to want to make sure that you're using the formula from the entry task. So let's go ahead and use that formula that we learned today. So quartile 3 plus 1.5 times the IQR. Quartile 3 is 1,560 plus 1.5 times the IQR, which you would need to do 1,560 minus 170. So use your PEMDAS, use your order of operations. Do 1,560 minus 170 first, then multiply it by 1.5, and then add it to 1,560. And when you do that, you should get 3,645. What that 3,645 tells me is that if I go back and I look at the maximum, if I look at the maximum that I have, the maximum number of my data is 73,996, which is greater than what I just found for 3,645. Okay, so because I have values in my data set that are larger than the number I just found for calculating my outliers, that would tell me that yes, I do have outliers in this data set. I don't know how many outliers there are because I'm not given any of the other numbers. However, I do know there's at least one with the maximum. And since the maximum and the 3,645 are so far apart from each other, I can assume there's probably a few more. So question 1B, if there are any outliers, why do you think they might exist? Well, I know there are, so why do I think they might exist? And then should they be included in the analysis of the data? Because a lot of times statisticians, we think to ourselves, is this outlier plausible, or could it be an error? Is it an outlier that is positively contributing to the data, or is it an outlier that's just an accident or a one-off that's getting in the way? If I look at this data and I think about how it's the number of passengers, specifically electric vehicles, that are registered, the 39 counties of Washington State has a really high population where we are in King County. And so I could see that the population of King County could have a pretty high amount of electric vehicles registered. Maybe 73,000, maybe more, maybe less, but overall there's a high enough population where I could see that that would be plausible. And then same thing with the electric cars being so small for the minimum. If you were to go out into one of the smaller counties in like northeastern Washington, up by like Omak or something, there might not be as many electric vehicles registered up there because it's such a small population, and so there might not be as much of a need for electric vehicles. So why do I think that the outliers might exist? I'd probably say it's because the population of the different counties in Washington State are different. Since you have some counties that have a higher population than others, that could be why there's such a big discrepancy with the outliers. Should they be included in analysis of the data for this specific problem? I would say yes. I would probably want to keep the electric vehicles in there. You might want to break it up if they wanted to into counties with lower population and counties with higher population if they really wanted to make it more accurate. But I think overall it's important to keep those in there. Let's look at a different situation and let's determine, or 3 other situations, and let's determine whether or not these situations, which all have an outlier, let's determine whether or not it's appropriate to keep the outlier or if we should remove the outlier when you think about analyzing the data. So this first one is, it says a number cube has sides labeled 1 through 6. So it's essentially just a 6-sided dice, but they're calling it a number cube. After rolling the cube 15 times, Tyler records his data. He gets 1, 1, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 5, 6, and then a random 20. So 20 is our outlier here. I want you to pause and talk about this with an elbow partner. Do you think 20 is a plausible outlier for this situation? Should it stay or should it be removed when you're thinking about the data? So pause, have a quick little chit chat, and I'll let you know. All right. So hopefully you've got a little chit chat. Technically, the outlier 20 in this situation should be removed. The outlier 20 should be removed for this situation here. And that's because it's impossible to roll a 20 on a 6-sided dice if it's labeled 1 through 6. So this is impossible. I have no idea how the student got it. I have no idea if it was an error, if they just wrote it down wrong, whether Tyler was trying to be funny, whatever happened. Either way, the 20 should be removed because it's not possible to roll a 20. Therefore, it does not belong in this data set. The dot plot represents the distribution of the number of siblings reported by a group of 20 people. I have 3 dots over 0 for 3 people who have 0 siblings, 4 dots over 1 for 4 people who have 1 sibling, 6 dots over 2, 6 people who have 2 siblings, 3 dots over 3, 2 dots over 4, 1 dot over 5, and my outlier over here, which is 12. So take a pause. Do you think 12 should be, 12 is a plausible outlier? Should it stay or should it be removed when you're thinking about the data for this problem here? All right. So the outlier of 12 is a plausible outlier, and so it should stay. Stay in the data. Although 12 siblings is not very common, it's one of those things where I guess you could make an argument to remove it. However, it doesn't specifically say in here whether or not step siblings or half siblings or anything like that would count. And so there is a chance where somebody could have 12 siblings in their family, and so we would want to include them. I guess you could make an argument for why you'd want to remove that 12, but technically having 12 siblings is a plausible option, and so if it is plausible, you might not want to remove it. Last one. In a science class, 11 groups of students are synthesizing biodiesel. At the end of the experiment, each group recorded the mass in grams of the biodiesel they synthesized, and the masses of biodiesel are as follows. In this problem here, 0 is actually going to be our outlier. We have a really low outlier this time. Oh, that's not a highlighter. Compared to all of the other values. Now this data is really small because we're talking about the masses of biodiesel, so 0 might not even be an outlier. I'd have to do some algebra first, but we're going to say I guess it could be considered 1 based off of the numbers we see. It's lower than all the rest. So I want you to decide based off of this problem, should the outlier 0 stay in the data or should it be removed? Why or why not? Give you a minute or two to think about that. This one technically could probably go either way. The outlier guess of 0 is plausible. However, most likely the teacher is going to want to have those groups of students double check their work, especially the group of students that got 0, because most likely the experiment might not have been completed correctly, especially since everybody else in the class all got some sort of a mass that was measurable. So most likely this outlier is probably incorrect and probably should be removed from the data, but more so the teacher should double check to see if the students completed the experiment correctly. Alrighty, that is all I have for you for today. For the rest of class, you need to finish this cool down, which hopefully shouldn't take you too long. When you finish it, please have either the sub who has an answer key or Mr. Jason check it off. And then the rest of class time is for you to sit quietly and work on something else. Please do not constantly ask to use the restroom or leave. You either have lunch in a few minutes or you are just coming back from lunch, so you should be just fine to wait until lunch, or you should have gone during lunch. Otherwise, please be kind and respectful and make sure you're getting all caught up with your work. Tomorrow we'll do our last new notes, and then Friday will be your test. Hope you all have a wonderful day, and I'll see you tomorrow. Bye!